In this session, we talk about two questions. Question number 1, what is the use of standard deviation? And question number 2, what is the standard deviation formula, or why is the standard deviation formula what it is? Now, to answer the question number 1, standard deviation is basically the average deviation of all the data points about its mean. So, one set of data with a larger standard deviation will have a more deviation about the mean compared to another set of data with a smaller standard deviation value. So, let us take up one example here. Suppose we want to find the standard deviation of this set of data. So, first you have to calculate the mean. So, mean is equal to -2 -1 plus 0 over 3, which is equal to -1. Then we calculate the deviation about the mean. So, it is -2 -1 -2 minus -1, which is equal to -1, and -1 minus -1, which is equal to 0, and then 0 minus -1, which is equal to +1. So, that is the deviation about the mean. Now, if we try to get the sum of the deviation, we always get 0. It is -1 plus 0 plus 1 in this case, but we always get 0 because that is how the mean is defined. So, that always x minus x bar summation is 0. So, we cannot do that. So, to avoid getting 0, we take the squares, because if we take the squares, all the values become positive. So, the sum cannot be 0. So, we get the square of deviations and then sum them up, and now we get 1 plus 0 plus 1. So, it is 1 plus 0 plus 1, which is equal to 2. So, this is the sum of deviation square of all the data points about the mean. Now, we take the mean of the sum of the deviation squared. So, I divide it by n. So, this is equal to 2 over 3. Now, as dimensionally this does not match, because dimensionally it is deviation squared. So, we have to take a square root of that. So, square root of summation x minus x bar squared over n is equal to square root of 2 over 3. So, that is the standard deviation of this set of data. Now, if we compare it with the standard deviation of another set of data, which is let us say -3, then -1 and +1. So, this set of data is obviously more deviated than this set of data. So, first we calculate their deviations from mean. Now, mean again here is -1. So, deviation is -3 minus -1, it is -2, this is 0, and this is 1 minus -1, that is 2. Now, x minus x bar square, summation of that is, this is 4, this is 0, and this is 4, that is 8. Now, summation x minus x bar square over n is 8 over 3, and then the square root of that is square root 8 over 3. So, the standard deviation of this set of data, which is obviously more deviated about the mean than this set of data, is a larger number compared to this one. So, that is the use of standard deviation to tell us about the deviatedness of one set of data compared to another set. So, it is basically a comparison tool, and this is the answer to the question number 2, because without this kind of a formulation we cannot get what we are trying to get. Thanks for watching.